Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we're here to suggest that mathematizing is not about mimicking or rote memorizing, but it's about thinking and reasoning, about creating and using mental relationships. That mathematics class can be less like it has been for so many of us and more like mathematicians working together, learning together. We answer the question, if not algorithms, then what? All right, y'all, on Facebook, we got a really cool message from Amanda McTavish Watson, who said, I got a teacher appreciation card from a young lady this week that said, thank you for helping me think, in all caps, T-H-I-N-K, think math. Made me cry, honestly. I always praise my girls for thinking math. It's not a favorite for many girls, and men dominate the STEM world. So here's one for Pam Harris and teaching kids to think math rather than do math. Amanda, I love that. Thank you so much for sharing that. That is amazing. Super cool. Super cool that your student recognized you during Appreciation Week. When we got this, it was a little while ago, but we're so appreciative that you sent that on. And way to change these young women's lives. That's excellent, excellent, excellent.
I love when people share what they're doing and how their kids are thinking based on what they're learning from you. It's so fantastic to hear.
Nice. Think math, not do math. Very cool.
Okay, so in the last episode, we introduced the idea of a clock model for adding and subtracting fractions. It is such a great tool.
Woohoo!
And we asked for which denominators would this model be helpful. And we asked y'all to think about what those would be.
Yep. Okay, so pause if you haven't thought about it. Pause first. Okay, go ahead.
All right. So that would be anything that is a factor of 60, right?
Yeah.
Thinking about minutes.
Yeah, clock model, minutes, that sort of makes sense. So with money, we get 100, factors of 100, and with clock, we get 60, factors of 60. Totally cool. When we started talking about fractions, I quoted a dear friend and colleague, Garland Linkenhoger, who said, if you really understand fraction equivalence, you do not need any rules for fraction operations. You can just reason your way through the operations. So true, so cool. Garland, I appreciate you throwing that out for me years ago. Let's get right at continuing to do that.
So today, let's do another problem string to help build equivalence using addition and subtraction. Are you ready?
I think
I'm
so.
going to give you some problems. All right. So you're thinking about a clock model today, and I'm going to ask you the first problem, which is 3/4 minus 1/3.
3/4 minus 1/3. So instantly, I'm thinking not money, because 1/3 money, yuck.
Uh-huh.
Clock, nice. I can think about 1/3 of an hour, so that's going to be really brilliant. So let's see. The first thing that comes to mind, I'm going to go ahead and do minutes first, even though actually 5-minute chunks came to mind first. But I'm going to do minutes in an attempt to kind of keep everybody with us today.
Okay.
So I could think about, well, and actually, in our last episode, we promised that we would do fractions that were more than unit fractions. So I'm just going to remind you that in the last episode, if you haven't listened to that one, go check it out, because we really talk about unit fractions. And today we're going to talk about how we can think about non-unit fractions. So 3/4, that's a non-unit fraction. The numerator is not 1/3. So I could think about 1/4 on a clock, and then I could think about 3 of those 1/4.
Mm-hmm.
And so that sort of puts me at 1/4 is 15 minutes. So 3 of those 1/4 would be 45 minutes. So I just wrote 45 60ths, 45 minutes out of the 60 minutes. And 1/3 I could think of on a clock as 1/3 of an hour. 60 divided by 3 is 20. So that's like 20 minutes out of the 60 minutes. So 20 60ths. So now I've got 45 60ths minus 20 60ths. 45 minus 20 is 25. So 25 60ths. That would be one way of solving the problem, 3/4 minus 1/3.
Nice.
I'd like to do another way
Okay.
for fun. And this is actually the way that came to mind first. I'm going to use 5-minute chunks. So where are the 5-minute chunks? Just to review a little bit, 5-minute chunks are sort of the numbers on the clock. Every time that minute hand goes to 1, that's 5 minutes. To 2, that's 10 minutes, right? Another 5-minute chunk. 3, that's 15 minutes. It's another 3 5-minute chunks. So I'm going to think about 3/4 of an hour in terms of 5-minute chunks. 3/4 of an hour is over there on the 9. And so that's 9 out of 12. So it's like 9/12.
Mm-hmm.
And then that 1/3 we decided was on the 20 minutes, or the 4. So that's 4/12. And so 9/12 minus 4/12 is 5 twelfths. I could kind of ask myself, 5/12, where am I on a clock? 5/12, that's like 25 minutes, right? Hey, that's what we got when we did minutes. We got 25 at 60th, 25 minutes out of 60 minutes. So 5/12, 25 60th, sure enough, same place on the clock, equivalent. Bam!
Nice. All right, here we go.
All right, next problem.
Okay. 3/4 minus a sixth.
Cool. I've already thought about 3/4 a little bit. So 1/6. So y'all, if you're listening to the podcast, you might pause it right now and see what you're thinking about. In fact, you could have paused it before, a little late on the game for me to tell you that. But maybe pause a little bit and think about 3/4 minus 1/6. Think about how you would do it and really push yourself, if you've never used a clock model, to think about it using a clock and maybe even a couple different chunks of time, and then come back and hear how I'm thinking about it. So let's see, 3/4 minus a sixth. I'm going to go ahead and do minutes first. So 3/4 of an hour is 45 minutes out of 60 minutes. And 1/6 of an hour, if I think about an hour, 60 minutes divided by 6, that's like 10 minutes out of 60 minutes. A sixth of an hour, 10 minutes of 60 minutes. So now I've got 45 60ths minus 10 60ths is 35 60ths. Cool. So I'm going to hope that when I do this with 5-minute chunks in a minute, 35 60ths, that I land on the 7. 35 minutes is on the 7. Okay, cool. So I'm going to think about this in 5-minute chunks. 3/4 of an hour, again, over there on that 45, that's like the 9. So 9 out of 12, 9 5-minute chunks out of 12 5-minute chunks. And then a sixth. A sixth, we decided, was at the 10-minute mark, because 60 divided by 6 is 10. So 10 minutes. What is that in terms of 5-minute chunks? 10 minutes is like 2 5-minute chunks. So that would be 2 5-minute chunks out of the 12 5-minute chunks, 2/12. So I've got 9/12 minus 2/12. That is 7/12. And bam, I'm on the 7 o'clock, which is what I was hoping for, because I'd also gotten 35 60ths. That's the 7 o'clock, and now 7/12. There we go. All right, cool.
Nice. Good.
All right.
All right.
Bring it on.
One more problem. You're on a roll. What is 11/12 minus 5/6?
11/12 minus 5/6. Y'all, on a clock model, it's just screaming at me, but I'll go ahead and talk through my thinking process here. Remember, pause a little bit, think about 11/12 minus 5/6 and see what you're thinking about. See if you can push yourself to use a clock model. Okay, 11/12 is screaming at me that I'm at the 11 out of the 12 5-minute chunks. So it's kind of like if I'm thinking about, what actually comes to mind? I'm thinking about a TV show and I'm saying to myself, I got 5 minutes left. Now there's dating myself, because I know nobody these days actually watches TV on the hour anymore, right? Like it's all like whenever you're streaming, which is true for me. But when I was growing up, everything was, on the hour. So I would have you don't care. All right. So 11/12 means I'm at the 11 o'clock, and 5/6. Well, I can think about 1/6 of an hour of 60 minutes is 10 minutes. And so 5 of those 10-minute chunks puts me at the 50-minute. So I'm kind of at the 55 out of 60. Subtract 50 out of 60 is just 5 minutes out of 60 minutes, or 5/60. But I was actually thinking about that as the 11 o'clock minus the 10 o'clock. And 11 o'clock, or 11/12 minus 10/12 is just 1/12. Cool. So I hope you can see, everybody, that as I'm sort of solving this using different chunks of time, that one of them usually falls out to be the most simplified. Not all the time, but often it does. But that's not the most important. I think we put way too much emphasis in the United States on simplifying and finding the most simplified answer. And I'll be frank with you, I think it's a lazy teacher thing. I think it makes it easier to grade. And so we have just over time demanded that kids always simplify their answer. It makes it easier to grade, and teachers have just been sort of lazy. Now, I'm not suggesting that maybe that's why you do it. Maybe you're not lazy. Maybe that was just the way you grew up. Your teachers did ask you to give you the most simplified answer. Textbooks do it. And so we just kind of have gotten this convention that we always do it. I'm pushing back on that convention. I don't think it's necessary. I think it is far more important that we find equivalent fractions, that we really develop equivalencies, and that we use a denominator that makes the most sense for us to solve the problem, and makes the most sense in the context for the answer. The answer might actually want one that is not the most simplified. So I'm going to push back on this idea that it has to be the most simplified, while pointing out that if I am flexible, I can often use a different chunk of time and get the most simplified, or take the answer that I've gotten and then use a chunk of time to simplify it. Let me give you an example. If I had just done the problem that we just did, 11/12 subtract 5/6, the answer we got the first time I did it with minutes was 5/60. Once I got that 5/60, I could actually stay there on that 5/60 and just, what's the word I want? Just hang there a minute and think about 5/60 in terms of chunks of time. I could say, well, 5/60, that's, let's see, 5 minutes out of 60 minutes. That's like I'm on the 1 o'clock, right? For where am I? If 5 minutes have gone by, I'm on the 1. And so I could say, well, that's just like 1 out of the 12. Bam! Right. And I've simplified using my understanding of equivalencies. But I'm going to suggest don't go there too fast with students. In other words, we're trying to give you an example of how we are suggesting use problem strings, use addition and subtraction of fractions to help students build equivalencies. You're going to work against yourself a little bit if when you do that, you always push for them to find the most simplified version of their answer every time. If you push every time, okay, I saw that you just used pennies, but now simplify it. Or I saw that you just used pennies, like I'm back in money. Or I saw that you used minutes, now simplify it. Or I saw that you used 10-minute chunks, now simplify it. If that's always your like gut, like go to like thou shalt emphasis, then kids are going to leave, they're going to lean away from the idea of just like, oh, how can I use this clock model to think about equivalencies? And they're going to be, it's all about the answer. It's all about the answer. And they're going to do one and only one way. They're going to do the way that comes quickest and easiest. They might use a calculator if they can. Like, we don't want to emphasize answer at the expense of thinking about equivalencies and relationships. Right. Okay, sorry, I totally just like broke into that string.
No, it's so good.
I think I have one more problem, right?
Yep, one more. All right, here we go. All right. 4 1/4.
Mixed number.
Mm-hmm. Miss a third.
4 1/4. Subtract a third. 4 1/4. So we promised you guys a mixed number. We want to make sure we got at least one of those in there. And really, nothing changes. I'm still going to use a clock to help me think about what's going on. Let's see. So 4 1/4. It's almost like I've got 4 hours and a quarter of an hour, and I'm going to subtract a third of an hour. I'm thinking about that. It's screaming at me. I'm going to do minutes first, even though the 12ths are screaming at me. I've gotten much better at the 12ths, at the 5-minute chunks over time. I'm going to do minutes first. So I've got 4 hours and a quarter is 4 hours and 15 minutes. So I'm going to write 4 15/60. Subtract a third of an hour. A third of an hour is like 20 minutes out of 60 minutes. So I've got 4 15/60 minus 20/60. I'm thinking about that on a number line, actually. I could do it on a clock. I could think about, now I'm going to do it on a number line. 4 15/60. And if I subtract 20/60, I'm going to subtract 15/60 first and land on the 4. And now I've got to subtract another 5/60 or 5 minutes. And so 4 hours minus 5 minutes, that's like 3 hours and 55/60. That would be one way to solve that problem. 3 55/60. Right?
Yeah.
Yeah. Okay, cool. Now I'm going to go ahead and do 5-minute chunks. So 4 1/4 is like 4 1/4 of an hour is like on the 15. So that's like 3 o'clock or 3 5-minute chunks out of 12 5-minute chunks. So 4 3/12. I'm supposed to subtract a third. A third is like at the 4 o'clock. So that's 4 5-minute chunks out of 12 5-minute chunks, 4/12. So I've got 4 3/12 minus 4/12. So again, I'm sort of at 4 3/12. I'm going to subtract 3/12 to get at 4. I've got to subtract one more 12. What is 4 minus a 12th? That would be 3 11/12.
Nice.
Yeah. And I'm I'm looking back. You guys can't look back unless you're writing along with me, but I had 3 55/60 or 3 11/12. And sure enough, those put me at the same place on the clock, right? 55 minutes and the 11 minutes. Yeah. Yeah. We're good. Woo!
Good. All right. So great. So we today used, actually last week or the week before, used money to work with denominators that were factors of 100. And then we've been working with a clock to create equivalents with factors of 60. But what about when there's denominators that are both factors of 160?
Bam.
Right? Well, that's when we give kids choice, right?
Absolutely.
Student choice.
Absolutely. Yep. In fact, I'll tell on us a little bit. We were thinking about the problem string to use for today, and we had a couple problems that were too choosy. And we thought, no, for this one, let's just make it like you have to use a clock model. You can't use either one. Maybe in the future someday we'll do some work in an episode where we have some choose your model problems. And maybe I'll just throw out an example where you could sort of choose your model. An example would be something like a half minus a tenth. Like I can use money, and money sort of screams, but I could also use a clock. No problem. Yeah. Maybe make it a half minus a 20th, and maybe you feel even more like being on a clock. But anything that is a denominator of both 160, then you have a choice, and you could use either model, whichever one feels sort of right to you at the point. And that's the real power. The real power is when people have the power to choose, not just one way to solve a problem, that traditional way where we just only thought about one way. So you might be asking yourself, okay, what about problems that have denominators that aren't factors of either 60 or 100? Well, we've built enough experience around equivalence by working with these models regularly that now we're ready for some double number line work and ratio table work to help students make sense of any denominators. So stay tuned to the podcast. We'll do more on that in later episodes. But the work with money and clock models lays such a great groundwork. And now students' fraction sense is so much better. And to be clear, once you have students really good at fractions and money using those models, so many of the problems they're ever going to hit in their life could be solved with those. Sure. Now, maybe not the problems that they hit in higher math, though honestly, often they are. There are other denominators, and we do need to work with them. But so many of the problems that they're ever going to hit, they could just think clock or money, and bam, they're done. They don't have to reach into rote memory to do anything, nor do they even have to reach into anything more sophisticated than just using clock or money. So here's a way to summarize what we've been doing in these last few episodes. Our friend Kathy Hale said, It's like you're using common situations, contexts, models to help students develop common denominators, or the need for common denominators. Yep, that's exactly it. Thanks for that, Kathy. We were in the middle of a workshop and she kind of raised her hand. She's like, I get it. We're using clock and money because there are these common situations, contexts that kids deal with every day to help motivate the need for them to find common denominators. Now, teachers, you might be thinking, Pam, you don't understand. Our kids these days, money and clock, those are not common contexts. Those are not common situations. They don't deal with change anymore. They don't read analog clocks. Okay. Kim and I will grant you that. We will grant that maybe our students, okay, not even maybe, that our kids have less experience with money and reading, especially reading analog clocks, telling time, having a sense of the relationships among 60. All the more important that we do this work with them so that we teach them both money, a sense of money, and time, and equivalencies with fractions at the same time. Like, this is going to be important. We cannot have students lose the sense of these important denominators of 100, factors of 100 and factors of 60. So we agree with you. Yes, your students have less experience with those. Then let's give them experience. If you're a teacher of younger grades, you've made it this far in the podcast. Absolutely wonderful. Do more work with your students with money and time. If you're a teacher who's teaching fractions, do work with the money model and the clock model to help your students both create both relationships, the relationships with money and time and the relationships with equivalencies with common denominators. So we get it, but that all the more important to do this kind of work. All right, fabulous. Remember to join us on Math Strat Chat on Facebook, Twitter, Instagram on Wednesday evenings as we explore interesting problems with the world.
If you're enjoying the podcast and find it helpful, please rate it and give us a review. That way more people can find it wherever they get podcasts.
So if you're interested to learn more math and you want to help yourself and students develop as mathematicians, then don't miss the Math is Figure Outable podcast, because math is figure outable.